Can you solve this MIT question? Well, let's discuss it, and please do subscribe to our channel first, and let's dive into the question. So the question states integral from 0 to infinity of the function 1 upon e to the power x plus 1. So how do we even start? Well, let's do some analysis to start the problem. You observe that the function is an exponential function, and you know a property that derivative of an exponential function is the function itself. Maybe this property can help over here. Let's see. If you have to use this property, then you must have an exponential term over here also, but you don't have. So what you can do is you can take e to the power x common. Okay. What's next? Let's see. You can bring this term to the numerator, right? It is equal to 0 to infinity of e to the power minus x upon 1 plus e to the power minus x dx, right? Is it correct? Yeah, it is correct. So now you can see if you take the derivative of e to the power minus x, it will be negative e to the power minus x, which is the derivative of this function, and it is over here in the numerator. So I guess now the question can be solved easily. And the fact you can take the derivative of the whole denominator itself to end up get negative e to the power minus x. 1 plus e to the power minus x is equal to negative e to the power minus x. So we can do a u substitution now. How? Let's see. Let's note this over here. 0 to infinity e to the power minus x upon 1 plus e to the power minus x dx, right? Okay. So what else can we do? I said a u substitution. E to the power minus x equal to u. If you derivate now, what you get? Du is equal to negative e to the power minus x dx, right? Okay. Which means e to the power minus x into dx is equal to negative du. Okay. And observe that as u tends towards 0, then 1 plus e to the power minus x, it is tending towards 2. Why? Because limit was not required here as such, but still 1 plus e to the power minus x, it tends towards 0, it tends toward 2. 1 plus 1, right? You can solve it, or just see e to the power 0 is equal to 1. That's it. And observe that limit as x is tending towards infinity, 1 plus e to the power minus x, it is tending towards 1. Do you agree to it? Why? Because limit as x tends towards infinity of 1 upon e to the power x is indeed tending towards 0, right? Which means the limits changed like this, from 2 to 1 of negative du upon u, right? Is it correct? Okay. So what's next? You know a property that integral from a to b of negative dx upon some function, or just fx negative dx, you can remove this negative sign and reverse the limits b to a of f of x dx, right? You can do the same thing over here. Remove the negative sign, reverse the limits, you get this. What's the integral of 1 upon u? It is simply natural log of what? Of u. Natural log of mod of u, but since the limits are from 1 to 2, means the limits are positive, so it don't matter much. It is going from 1 to 2. Now substitute the limits. Ln mod 2 minus ln mod 1. What is ln mod 1? It is 0. Ln 2. So we just solved the MIT question. I hope you all enjoyed the video and understood the concept. So please do subscribe to my channel and support my channel, please. Thanks a lot for watching it.